Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to solve the problems on friction on an inclined plane. So far we covered in previous sessions horizontal plane. We solved problems on horizontal plane. Now in this session, as I mentioned here, the problem here it is mentioned it is on inclined plane. A body of weight 500 newtons is lying on a rough plane inclined at an angle of 25 degree with the horizontal. It is supported by an effort P parallel to the plane as shown in figure. There is a P parallel to the plane, parallel to inclined plane is shown in figure. Determine the minimum and maximum values of P, and for which the equilibrium can exist. If the angle of inclination, if the angle of friction is 20 degree, here in this problem we have to find out P maximum and P minimum. Okay, P maximum and P minimum are to be calculated. The angle of friction is different from angle of plane. Here the angle of plane is 25 degree, whereas angle of friction is 20 degrees. Okay, and the weight of the plane, the body weight on inclined plane is 500 newtons. And what to be found? P maximum and P minimum, where P is the effort, is on inclined plane. Now we have to find out P maximum and P minimum. Let us begin with how to solve the problem here. For the given data, here it is, the weight of the body is of 500 newtons and the angle of plane inclined is 25 degree and the angle of friction phi is 20 degrees. Now we want to find out the minimum value of effort P. So the minimum value of the P, here we want the minimum value of the P means the body at the point when is required minimum value of the P. Here when it is the body is sliding downwards, it becomes minimum value of the P. Yes, here this is inclination of the plane. This is the body. When the body is moving downwards, what will happen? It becomes, when body is sliding, the body is sliding downwards. When the body is sliding downwards, what will happen here? Sliding downwards, it becomes minimum value of the P is required here. Is the P minimum. When the body is moving upwards, if your body is moving, then we require more force. That is called maximum effort is required. On your sliding, when the body is sliding, yes, it is sliding. What is effort? Less effort is required. And we want to move the body on inclined plane upwards, then what will happen here? We need more maximum force. So further, we have already derived expression in previous sessions, that is P sin alpha minus phi by cos phi. That is P sin alpha, P1 that is equal to W1 times sin alpha minus phi by cos phi. Here, even though we are showing the friction force and all, this diagram indicates the diagram which is mentioned here. Okay, for which the body equilibrium exists. But according to the first minimum value of the P consideration, for the minimum value of the P consideration, effort P is required. Yeah, the sliding downwards, when it slides downwards, the direction of the motion of the body, the P is here, the P point, the body movement is going downwards, it is moving downwards. What about the direction of the friction force? The friction force acts upwards. The direction of the motion of the friction force, it moves upward direction. By using this consideration, and weight is acting W, acting downwards, and the normal reaction normal to that, this is the angle of inclination 25 degree. By using parallel to the plane and normal to the plane equilibrium conditions, we derived already expression, that is P1 equal to W times sine alpha minus phi by cos phi. So here, what is the W here? 500 newtons. Sine times alpha. What is that alpha here? 25 degree, and phi is 20 degrees. Here alpha is the angle of inclination of the plane, 25. Whereas phi is the angle of the friction, that is the tan phi. So mu equal to tan phi. Here the phi is the angle of the friction. Substitute over here sine times alpha minus phi by cos phi. Then that is 500 times sine phi by cos 20 degrees. Sine 25 minus 20, sine 5 degrees by cos 20. That is 500 times sine 5 degrees. That is 0.0872 by 0.9397. That is 46.4 newtons. That is the minimum value of P. Okay, next, what is the maximum value of the P consideration? For that maximum value of the P consideration, what will happen here? Again 25 degree. The body moves upwards. Here it is the P is the effort. It is upward direction only. Well, now the motion of the body is upward direction. Whatever friction force, it goes downward. This is the direction of the friction force. Now the weight is W, and the normal reaction is how much? The normal reaction is normal. The angle is 25 degree. Resolve this component along and normal to the plane. That is W in this direction. W cos 25, and whatever normal to this is W sine 25 degree. Now this is the parallel and perpendicular. What about equilibrium? Now R plus W cos 25 equal to 0. That is R equal to W cos 25 minus. Next one is weight, the parallel to the direction. What is the parallel? Here F is the one, effort, and W sine 25. There are three components are there. That is F minus direction minus F minus W sine 25 equal to P. Now what is that? F equal to mu times R. F equal to minus mu times R minus W sine 25 equal to P. Minus mu times, what is that? R equal to W cos 25 minus W cos 25 minus plus, that is W cos 25 minus W sine 25 equal to P. Here mu equal to tan phi R. This is another method. Now we are going to discuss another method also, but we already derived the expression for this case, that is mu P2 equal to maximum value of the P, that is P2 equal to W times sine alpha plus phi by cos phi. Yes, this is the maximum value of the P, that is W times sine alpha plus phi by cos phi. That is 500 times sine 25 plus 20 degrees by cos 20 degrees. Then 376.2 newtons. This is the one method. We already derived expression and substitution into that expression and getting the answer. Another method is that suppose we have forgotten those expressions. For the case study, we don't know whether the same case study or not. Then what to do? Another method, another alternative method is that going for the concepts of friction, that is equilibrium conditions. Suppose when the body is on inclined plane, the motion direction is downwards, the effort will be upwards. This is the effort, friction force. The effort is the P is upwards only, whatever it is. The angle of friction alpha and the angle of friction is the phi. Now the normal reaction, the weight acts downwards and the normal reaction is R. The angle is alpha. Then what about here? Normal to that is this R is the normal to the inclined plane. That is W in this direction, W cos alpha, and another direction is W sin alpha. Now apply equilibrium conditions parallel to inclined plane and perpendicular to inclined plane. The parallel to inclined plane, what are the parallel to inclined? What are the forces are? Parallel to inclined plane, this is F is the parallel, effort P is the parallel, and another one is W sine alpha also parallel but in downward direction. So consider that downward direction is negative and upward direction is the positive in parallel to inclined plane. That is F plus P minus W sine alpha equal to 0. That is F equal to W sine alpha minus P, or P equal to what will happen here? F minus W sine alpha. This is equation 1. What is that? F equal to mu times R. That is next. That is F equal to mu R, the minus W sine alpha. That is P. That is the same. That is for equation 1 is again for the made into, okay, simplified. The next step, what is the next step is perpendicular to normal to the plane. What is that normal to the plane? That is R and W cos alpha. R is going upwards, not perpendicular or normal to the inclined plane. Upward direction is positive, and that is equal to downward direction. That is W cos alpha. R equal to W cos alpha. Now R equal to W cos alpha. This is substitute 2, equation 2. Substitute this equation 2 in equation 1 where R is there. That is mu times W cos alpha minus W sin alpha. Now this is P. What is that? Effort P. Minimum effort. Substitute mu equal to tan phi or sin alpha minus cos alpha. If we make it further simplification, we can get it as we can derive that expression, or we can substitute here what is alpha. Now mu equal to tan phi. Now P equal to final equation, that P equal to mu equal to tan phi times W cos alpha minus W sin alpha. What is the tan phi here? Phi angle, that is tan 20 degrees. W is 500. Cos alpha, cos 25 degrees minus 500 sin alpha. Sin alpha, what is the angle? Sin 25 degree. You will get the same answer, minimum, P minimum. Okay, that will come as 46.4 newtons. 46.4 newtons you can apply, will get it. That is analytical method, and that is another method. Now that is for first case 1, P minimum I considered. If you want to go for P maximum, the maximum value of the P, how to get it maximum value of the P? Again, go for the analytical method, that is maximum, P maximum. How it comes P maximum? Again, body moving upwards, the friction force is downwards, is the W, and normal reaction is normal to the body. Now what about here? That is alpha is 25 degree, that is W cos 25, and parallel to that, this is W cos 25. And next, what about perpendicular? This is, yes, W sin 25. Apply equilibrium conditions parallel to plane. If you want to apply equilibrium conditions parallel to plane, what are the equilibrium conditions parallel to plane? F is moving downwards, negative, and P is moving upwards, positive, and W, what happened here? It is W cos 25 equal to 0. Now from that, P equal to W cos 25 plus F. This is the equation 1. What is it? F equal to? That F equal to friction force. F equal to mu times normal reaction. That is cos 25 plus mu times R. That is the P maximum in this case. What about R? We know mu equal to tan phi. R equal to, we need R comes from normal to the plane, normal to the inclined plane. That is perpendicular to inclined, perpendicular to plane. What is the perpendicular to plane? That is R. R is moving upwards. This is the R equation. R. Whatever R. Another one is that W cos is perpendicular. Here, what will happen? W here become W sin 25. And here W cos 25 is normal to the plane. That R minus, what happened here? Yes, double R upwards, R plus W cos 25 equal to 0. Then R equal to minus W times cos 25. Substitute that R value here. W times sine 25 plus tan phi mu equal to tan phi. Then substitute W minus W times cos 25 here. If you substitute W equal to 500 newtons sine 25 plus tan phi tan 20 degrees and again cos 25, then P maximum value can be obtained. So in this problem, there are two methods we use. One is formula based, another one is by using analytical method. There are the two methods. We use the two methods to solve the problem. Okay. Next one. This is what. Next problem, if you see, an inclined plane is shown in figure, is used to unload slowly a body weighing of 400 newtons from a truck 1.2 meters high into the ground. A truck 1.2 meters high into the ground. The coefficient of friction between the underside of the body and the plane is 0.3. The coefficient of friction. The truck height is 1.2 and the weight is 400 newtons. State whether it is necessary to push the body down the plane or hold it back from sliding down. What minimum force is required parallel to the plane for this purpose? What minimum force is required parallel to the plane for this purpose? Minimum force is required parallel to the plane for this purpose. This is 400 newtons. This 2.4 and 1.2. 2.4 meters and 1.2 meters. So 400 newtons weight. So now here the angle of inclination was not given. What is the angle? But tan phi, the angle of friction, that is mu equal to 0.3. And the weight W equal to 400 newtons. So what to be found here? The what minimum force is required parallel to the plane for this purpose. Now state whether it is necessary to push the body down the plane or hold it back from sliding down. Let us begin. So first case, whether it is necessary to push the body down the plane or hold it back from sliding down. For that, what to do? First we have to find out that is tan alpha. What is the inclination? Tan alpha is not given. We do tan alpha equal to opposite side by adjacent side. What is the opposite side? 1.2 meters. Adjacent is 2.4 meters. 1.2 by 2.4. 1 by 2, that is 0.5. And alpha equal to 26.5 degrees. This is angle of inclination of the plane, 26.5 degrees. Now, normal reaction. What is the normal reaction here? How to get a normal reaction? That by resolving the component, that normal reaction and W, what will happen here? That R equal to W times cos alpha, that is 400 times cos 26.5 degrees. That is R equal to 400 times cos 25 equal to 0.8949. That is 357.9 newtons. How we got this equation? Yes, look at here. This is our reaction. This is angle of inclination is alpha. If you resolve this, the W equal to 400 newtons with the horizontal. This is horizontal, that is W times cos alpha. R also in this direction, or this is W cos alpha. What about opposite component? Parallel to it becomes normal to the plane component, but with this W it is a horizontal component. Parallel to the component, this is W sin alpha. Now resolve the equation, use apply equilibrium conditions. Normal to the plane, normal to the inclined plane, are equal to, yes, normal reaction equal to, yes, W is downwards, no, yes, this is downwards condition, yes, W R upwards positive minus W cos alpha equal to 0. Then R equal to W cos alpha. Here in the before problem also we considered here R plus, no, the W is acting downwards, R is upwards. So R minus W cos alpha, R equal to W cos alpha. Here that is also, that is W times 25 plus tan phi times W cos 25 here, because W is downward direction, W cos 25 is, yes. Now this is downward direction, that is R is upward positive, minus W cos alpha equal to 0, then R equal to W cos alpha. R equal to W times cos alpha, that is 400 times cos alpha 0.8949, that is 357.9 newtons. The next is force of friction. What is the force of friction? F equal to mu times R. What is the mu equal to 0.3 R? Just now value calculated. The calculated value of R is 357.9. Then observed value is 107.3 newtons. This is F value. Now we are going to resolve the component force along the plane. Now what is the along the plane? Whatever the along the plane, that is F equal to whatever here, that is 400 times sine alpha. That is 400 times sine 26.5, that is 178.5 newtons. Okay. Now here we calculated, there are two values. One is normal force, another one is along the plane. That is what is the friction force we calculated. The friction force we are going to compare here. Friction force, now the force along the plane required, this is 178.5. This 178.5 is greater than the friction force. That is greater than the friction force. That's what, by using these two values, by comparing these two values, we are going to give conclusion that whether it is necessary to push the body down the plane or hold it back from sliding down. You can understand. Here the force is coming down is that 178.5, but what is the friction force? 107.3. It is 178.5 is greater than the value of the friction force. Then no need to push. Is it necessary to push the body down the plane? No need to push. What is required? Hold it back from sliding down. It is sliding down because the force is greater than the friction force. That means it is sliding down. That what? As the force along the plane is a responsible force for sliding the body. Is more than the friction force of friction. Therefore, the body will slide down. Or, in other words, what to be done? It is not necessary to push the body down. Rather it is necessary to hold it back from sliding down. So this problem is the real field problem. It is highly important to understand. We have to push the body down or not. We have to calculate two things. One is frictional force, another one is the sliding force, that is parallel to the force sliding. Okay, what is the next force is required? What is the next condition? What is the minimum force is required parallel to the plane for this purpose? The minimum force is required. What is the minimum force required parallel to the plane? The minimum force required parallel to the plane to hold it back. What is minimum force? That is the difference between parallel to the force, sliding down the force, and friction force. That is 178.5 minus 107.3. This is 71.2 newtons is the minimum force required. Okay, minimum force required parallel to the plane to hold the body back. Next, final problem here. Now, what is next? Final problem is that an effort of 200 newtons is required. An effort of 200 newtons is required just to move a certain body. Just 200 newtons is required just to move a certain body up an inclined plane of an angle of 15 degrees. The force acting parallel to the plane. If the angle of inclination of the plane is made 20 degree, the effort required 20 degrees made 20 degree, the effort required again applied parallel to the plane is found to be 230 newtons. Find the weight of the body and the coefficient of friction. We need weight of the body and another one is the mu, coefficient of friction. These two things are required. So from this data, the angle of inclination here, first of all, this is the obtained figure. How it is moving down? Yeah, it is moving up. The force of friction is acting downwards. Now first, whatever, consider the body lying on a plane inclined an angle of 15 degrees with the horizontal and subject to the effort of 200 newtons, which is shown in figure. Now resolving the force along the plane. Now we have to resolve here the description, the body lying at 15 degrees. it is at 15 degrees. The friction force is downward, that means body moving upwards, the 200 newtons. The normal reaction, if you resolve, that is W, whatever parallel, the normal to the plane, downwards W cos 15 degree, and parallel to the plane, what is the parallel to the plane? That is W sine 15 degrees. Okay, now resolve it. The parallel to the plane, what is the parallel to the plane? F1 plus W sine 15, that equal to 200 newtons. The 200 newtons in opposite direction. One is both are downward direction equal to upward direction. That is F1 plus W sine 15 equal to 200 newtons. What is F1 equal to? Mu times R1, that is sine 15. Mu times, what is R1 equal to? What is R1 equal to? How to calculate R1? That R1 equal to W sine 15 will come from by resolving, by considering the forces perpendicular to the plane. R1 is upwards, that is R1 equal to W cos 15. Substitute in the place of wherever R1 equal to is there, W cos 15, that is W equal to mu cos 15 plus, make it common W, mu times, W make it common, mu cos 15 plus sin 15. Now substitute here, what is the mu value? We need a mu value also W. So this is one of the equation. Okay, the another equation, what we are doing is that now consider the body lying on an inclined plane at an angle of 20 degrees. Again 20 degrees with the horizontal. Now before is 15 degree, now it is 20 degrees. You apply same methodology. The methodology is that we have to apply again, resolve it. This is W cos 20 degrees and this is W sin 20 degrees. Now R2 equal to W cos 20 degrees. Now F2 plus W sin 20 degrees equal to 230 newtons. Now 230 newtons equal to F2 plus W sin 20. What is F2 equal to? Mu times R2 plus W sin 20. So mu times, what is that R2 equal to? W cos 20. Substitute here W cos 20 in the place of R2 and W sin 20. Then W make it common, 230 times W times mu cos 20 plus sin 20. This is equation 2. Now there are two equations and two unknowns. W and mu are the unknowns. So equation 2 by equation 1 or equation 1 by equation 2, if you do it, then you will get it one of the parameter. Now make it, divide the equation 4 by equation 2. This 230 by 200. Then W get cancelled. From that, cross multiplication, after doing cancellation and cross multiply, 230 times mu cos 15 plus 230 times sin 20 equal to 200 times mu cos 20 plus 200 times sin 20. Now 230 times mu cos 15, we make it sin terms one side and cos terms another side. Make it cos terms left side here and sin terms right hand side. That is 230 times mu cos 15 degrees minus 200 times mu cos 20 degrees equal to 200 times sin 20 degrees minus 230 times sin 15. Now make it common term, that is mu, coefficient of friction. 230 times cos 15 minus 200 times cos 20 equal to 200 times sin 20 minus 200 times sin 15 degree. From the then mu equal to 200 times sin 20 degrees minus 230 times sin 15 degrees by this term. That is 230 times cos 15 degree minus 200 times cos 20. After substitution here, what is sin 20 terms, sin 15, cos 15 and cos 20. The observed here, the calculated coefficient of friction is 0.259. This is the first parameter here, mu. We want to weight W. How to get it W? Substitute back this W in the one of the equation, above mentioned equation. That is here 230 equal to mu times W times mu cos 20 degree plus sin 20 degree. 230 times W. What is the mu value? That is 0.259 cos 20 degree plus sin 20 degrees. From that, what will happen here? W value will be obtained. The W value here, substitute which term we used here, cos 20. Here, use it here in second equation, but I used here one equation. Here, second equation cos 15 and sin 20. Here, yes. Here, point 200 times equal to, wait, cos 15 and sin 15. Yes, cos 15, sin 15. Now, what to do here? There is a term made cos 200 equal to, no, here sin 15 term should be there. So, be careful here while solving the equation cos 20, 230 times cos 20, 200 times, yes, cos 15, sin 15. Then what will happen here? 230 times, yes, sin 15. Yes, nothing wrong. Now, if you substitute here sin 20 and cos 20, then W will come value. And or if you substitute in that equation 200 equal to mu times W times mu cos 15 plus sin 15. If you substitute there also, the weight observed, the observed weight is here, that is 392.9 newtons. 392.9 newtons, that is W. Okay, there are three varieties of problems. One is calculation. The last model is calculation of two parameters, calculating weight and coefficient of friction. In model 2, what we have calculated, the calculated here it is whether it is the what type force is required to push down the body or not required. That is the condition you have to fulfill. That is the force required, and what is the minimum. Okay, so force is required. What is the minimum force required to slide down? So for this case, there is a model number 2. For the minimum force is required, even though the force calculated here it is, the force calculated is how much? 178.5. Already it is with that force it is coming out. But what is the minimum force is required here? The 71.2 newtons minimum force is required. That is model number 2. And model 1 is the maximum, P maximum, P minimum calculations. Okay, let me summarize. There are three models covered here. Model 1, Model 2 and Model 3. Model 1, minimum force, minimum effort and maximum effort requirement. Model number 2, what is the minimum force is required? Minimum force required. And second objective, first object, actually this second object, what is the first objective is that whether the body is sliding, whether it is sliding or not. If it is sliding down, what is the minimum force is required? What is the condition? That's what. Whether it is it necessary to push down the body on inclined plane? That is what model number 2. To push down, whether is it necessary to push down? It is not necessary. Then what is already it is under motion condition. Maximum force is coming out. So we need the force to hold it back. That is what. Second model is very, very important model. And third model calculation, in the third model 3, we calculated weight and coefficient of friction mu. And under there are two things. There are two angle of inclinations. One is 15 degree and another one is 20 degrees angle of inclinations. One is 15 degrees angle of inclination. Another one is 20 degrees angle of inclination. Okay. There are three models covered. And these are the three important models. In the coming session, next session, what we are going to do is that we are going to study a application of the friction. Before going to study the application of friction, what is the friction? We have studied already. What is the limiting friction? What is the frictional force? What is the relation between normal reaction and the frictional force? That is mu equal to F by R. And another one is what is the loss of friction. And we solved that since last 3 sessions, 3 classes, we solved the different varieties of problems. One of the problem is that one of the case studies that horizontal plane consideration. In a horizontal plane, it's a single body. On a horizontal plane, multiple dual bodies. And again on inclined plane, here we studied a single body on inclined plane. Okay. And in the next session, application of the friction. What is the application of the friction? One of the application of the friction is application of the friction. Application of friction is that one is the ladder friction. Okay, and another one is a wedge friction. And the third one is friction between a screw jack. Is also another friction. Okay, these are applications of frictions. So in coming sessions, we study what is the ladder friction, how to solve the problems. Why ladder friction is the application of the friction. The ladder, in olden days, the wall, here it is the wall, here there is a wall, and that there is a ladder. Okay, in order to nail it, the nail on the wall, or in order to fix and anything, any electrical equipment, we need a ladder. So this ladder is side view here, you're looking, but generally ladder seems there are two strung columns will be there in between. These are called rungs. Okay, there are 1, 2, 3, 4, 5 steps, like a steps going on. Now it is inclined here. In order to hold on that, there is a friction. The motion tendency of this point in this direction, motion is whatever friction force, it acts in opposite direction. When it is moving, this point is moving in this direction, what about motion of this edge? This edge is going downwards. What about friction force? It acts upwards. There will be narrow reaction, the normal reaction, normal to the surface. Here normal reaction. Normal reaction, frictional force, F. Here normal reaction, frictional force. Alright. So we use again equilibrium conditions and we solve again what is the coefficient of friction, what is the normal reaction. Okay, let me I already summarized. Okay, with this we can close the session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.